I am Hilali, Professor Buet. I'd like to invite all of you to my lecture. Today's lecture is based on Bangladesh National Building Code, Part 4. The module is NS3. Out of this Part 4, I will cover Chapter 4, 5 and Appendix B and C. This part contains equipment and built-in facility standards. That is this. We shall talk about the extinguishing system and their standard in this part. The provision of this chapter shall control the standard design, installation and maintenance of equipment and built-in fixed facility or localized facility or portable facility. Extinguishing agents may be water, dry sand, ash, inert gas, dry chemical, wet chemical, or mixed. This will be based on the type of fire. You know, there are different types of fire which we designate as class A, B, C, D, K. Depending on the type of fuel or type of material when it burns, type of classes depends on, and the type of extinguishing agent will be also based on the type of fire. So the gaseous system shall be used, water or foam cannot be used. Fixed type fire protection system means there are some pipe circuit to cover full or part of the building. There are some localized system like ball or sand grenade in this form, which you can put inside some cabinet or in some area. So when the temperature right, it will burst and ignite and it extinguishes the system. There are some portable system which we use as a hand carried system. Normally it is used by inmate of the building at the time of fire. So you understand that all extinguishing system or type of system will depend on type of fire. So I like to give some brief idea about the type of fire. Actually, inside the building, the house, mostly it is class A fire. It's a residential building, but there are other type of occupancies that may involve flammable liquids, gas, that is the class B fire. And there are some electrical equipments in computers that will create a class C fire. And if there is some combustible metal like magnesium, lithium, sodium, they will give a different type of fire. So that will be class D fire. And in the kitchen, if there is a cooking system, cooking oils, fats, that will give you class K fire. So we have to choose our extinguishing system depending on the type of fire. So if you do not know the source of fire, then you should not use randomly for any extinguishing system. But in general, we use water because most of our household system is involved with wood, paper, plastic, etc. And so most fire is class A fire. In other thing, we have to consider the safety of the system. Actually, water is the best safe extinguishing system which can be easily used. Other type of system, gaseous or the other things, are not very safe system because they will create some toxic environment. So it is not very good for the inhabitants of the building. So you have to be very careful about using other than water as the extinguishing system. So we start like to a hydrant system. This is a fixed water system. This is most widely used for Class A fire. This comprises of a standpipe hose in the rail form or in the rolling form. And there is some sprinklers, which is automatic system. There is dancers or similar combination. So all for the type Class A fire, we use this hydrant system. To start with the hydrant system, you need some water which must be available near to the occupancy. It can be a hydrant fixed by the local government very near to your occupancy. In the street there is some hydrant from where you can have water. Unfortunately, no city or no area of Bangladesh we have this hydrant system, but most of the big cities of the world, they have hydrant system. In that case, we need some water source to cope with this our hydrant system. In BNBC guide, it is suggested that you have some water main connection, and that main connection should be the hydrant system, which is not existing. So we need some tank or pond or nearby anything which will work as a source of water during the event of fire. For the occupancies, it is suggested to have a roof gravity tank or a storage tank underground or elsewhere. So now you can see a typical diagram of a hydrant system with a ground water tank. Because you have to deliver your water to different height or different story of the building at different level. So to pressurize the water, you need a pump. In the diagram you see there is a pump, and there are actually two pumps. One is pressurizing pump that we call jockey pump also. That is used to initially pressurize all the area of the piping. So at the time of event of fire, you can have it very quickly so that we can start spraying water to the fire very quickly. So there is a tank in the drawing that is under the ground. So it will be filled up with some reserve water so that in the event of fire, there will be no delay of water supply. And the tank will be fed from any source. It can be your underground deep well tube or local water supply. In Dhaka, it may be Washa or anything, or it can be any private arrangement to fill it all the time. So water is available at the tank. During the fire, when you are extinguishing this, if there is a shortage fire, so when the fire department come, they can also fill it by a local connection. We call it Siamese connection. By using Siamese connection, fire department directly can put to the hose system, or they can put in the reservoir if needed by using different arrangement of valves. In the event of fire, when there is a pressure, you start the pump will deliver water to all floor where you can have hose system with a valve. Opening your valve and targeting your hose nozzle to the fire, you can spray as desired. This is a simple system with gravity tank. If you don't have a gravity tank, if you have a rooftop tank, if the tank is at a definite height such that the pressure required for spray will be sufficient due to its gravity. Actually, we cannot put the tank on the top of the floor. In that case, in Dhaka city, particularly in Ajimpur or in Fakirapur, there is supply reservoir water, very high. If it is directly connected with those type of system, you may have sufficient pressure to spray. In that case, you may not require pressure pump, but it is a normal. It is not normal in Bangladesh. So in general case, almost all area of Bangladesh, you should have a pressure pump. If you like to have a sprinkler system with this, then again you need the pressurizing, always this pressurizing the system at that type or at that type event of fire when this sprinkler is heated and it will burst out, and automatically the jockey pump and the pressure pump will activate it and you will get water sprinkled on the system.
Excuse, excuse me,
Hello?
Professor Halali.
Yes?
Can you put up your volume a little bit, or speak up a little bit higher?
Is it higher? Is it not? Now you can hear me, please.
Yeah, I can hear you.
Okay, okay. Thank you. Thank you.
Thank
Okay. Then water hydrant system can be directed to that main, which I tell you with us now, and you make the direct connection with the roof gravity tank, which I say. Actually, you need the pressure at the nozzle tip, which is 200 to 600 kilopascal. If you have nozzle for the first aid firefighting system, that is the inmate of the world, if they like to fight, if their hose system is around 38 millimeter diameter, then the pressure at the tip is 200 kilopascal. If this hose is used by the firemen, and in that case, if the hose diameter is more than 2 inch, then their pressure should be 300 pascal. And if it is used by the sprinkler, then pressure will be the 600 kilopascal at the other end. So depending on the type of system, there is some variation of pressure, and accordingly we have to create pressure in our design of this hydrant system. When a system is built up, it should be tested according to the NFPA 25. Actually, BNBC suggests to use the NFPA 25 at the procedure of testing our hydrant system. The testing procedure ensures the flow and the time of the system. Here I am showing a water reservoir or underground water. It may be underground and or maybe river tank. This is to ensure the water fire reservoir such that there will be always a level of water for water reservoir. You can see the tank here. If you use a single tank for your domestic supply and fire reservoir, so your domestic supply line should be opened at a certain height such that always there will remain some fire reserve water. In no case it will be drained out by domestic requirement. So there will be always a certain amount of water for firefighting. But there is a problem if this is the design. You can say the lower portion of the water will not recirculate. In Bangladesh, there will be always mossing. That means fungi, algae will grow very fast, and there will be some sedimentation deposition. in that, to protect that one, you should need to design such that the water from the bottom will circulate during the domestic resource. So you see there is opening in the bottom, water will be drawn always from the bottom. So there will be no stagnation point in the tank, such that there will be less chance of deposition of moisture. So this is an idea of how we can recirculate, but to make it very effective recirculation, you can use other mechanical system for recirculation. Normally, we do not use recirculation, so always there is some sedimentation or this. So time to time, it has to be drained. There is a rainfall, it has to be drained off, and it will be clean. But you understand, cleaning is a loss of water, huge amount of water you have to drain out, is a wastage. So you have to be careful about the waste also. The capacity of the tank is calculated based on the requirement of our flow. Table 41441, I will show you to how to calculate what is the tank reserve size for your firefighting. This is the table from where we can calculate how much water we should keep reserve in reservoir and what should be the size of our reservoir tank. So in this figure, in the left side, you see the type of hazard of your building: light hazard 1, light hazard 2, ordinary hazard 1, ordinary hazard 2, ordinary hazard 3. And you can see the occupancy type and the hazard in the bottom of this table. So depending on your occupancy, you can choose, you can select your occupancy hazard classification. Based on the classification, you will choose what amount of water you have to reserve or you have to make a flow for the extinguishing of the system. As for example, if you have a garments industry, as if it is think is G2 is the occupancy, then our hazard classification is ordinary hazard 2. In that case, for the sprinkler system, you have need about 3200 liter per minute of water for sprinkler system, and for a standpipe you need 1900 liter of water per minute. Again, this flow is a per minute. How much time you need to reserve, it is again depends your building height. So if your building height is within 51 meter, you will take 75 minutes. If your building is more than 51 to 102 meter, then you have to for 95 minutes. If your building is above that, you need much more time here. So if I think about our low-rise building, garments factory, then we have to, for standpipe, we have to take 19 liter per minute of water and multiply by 75. That is the amount of water you have to reserve for your garments industry or an occupancy. If it is again with a sprinkler, then you have to multiply 3200 into 75 minutes. If it is combined system, then you have to calculate the maximum requirement, either sprinkler or a standpipe, then you have to go for the higher one. Please note that values will be for one riser serving floor area 1000 meter. So if your occupancy size is more than 1000 meter square, then you have to add something more, which is written in the following. In the standpipe system with more than one standpipe, the minimum flow is specified in the table 4.1 for the first standpipe plus 1000 liter per minute for each additional standpipe. So you need something more if your build is more than 1000 meter square, and depending on that you have more standpipe, and for each extra one standpipe you have to add 1000 liter per minute, and similarly you have to increase if your standpipe is more than 3, 4, 5. But there is a limit. If it is more than 8, do not add anything. So maximum you will add up to 8 standpipe. Roughly, if you have a floor area about 1 lakh square feet, more than 1 lakh square, you may need around 8 standpipe extra. So this is a rough calculation of water tank with water tank size. Here are a few points about the fire pump. So the firefighting system shall be directly fed by automatic main fire pump. Fire pump may be centrifugal pump, turbine pump. Turbine means it may be servos with vertical shaft, or any positive displacement pump. Positive displacement, in that case, we can use as a reciprocating pump, we call a positive displacement pump. But in general, normally positive reciprocating pump has its flow rate is is not very high. So in that case, you have to think about the amount of flow whether your pump can handle. Normally, a centrifugal pump, turbine pump can handle huge amount of flow, but if you need very high pressure, then you have to go for positive pressure, particularly reciprocating pump. Please remind that centrifugal pump shall not be used where a static suction lift is required. This is a different thinking which was not in BNBC 2006. During actually NFPA 2016, before 2016, there is no provision of that one. They in NFPA they added this new thing in after 2016, that centrifugal pump should not work under the static suction lift, though it can work. Normally, whatever you see in the firefighting engines, firefighting vehicles, almost always they use centrifugal pump, but they work on static suction lift. But for the reliability in the new NFPA, they suggest centrifugal pump should be always positive, anytime. Once the pump starts, it shall run continuously until stopped manually. The pump shall be fully operational within 30 seconds. There should be provision for manual starting where priming is necessary. Automatic priming equipment is necessary to ensure priming at all the time. You know, as you have jockey pump, that will always ensure your priming also. The fire pump shall not be used for other purpose. The pump shall have the rated capacity as shown for I'll show you later. Fire pump install procedure and fittings and appear shall be followed. Actually, in a hydro system, fire pump is very a critical thing. So you have to be very careful about the pump and its capacity and the flow capacity. So the pump shall be housed in a readily accessible position in a building of non-combustible construction. Normally, the building of the firefighting pump is 1 hour fire protected. The pump shall be adequately protected against mechanical damage. There should be provision for secondary pump, which can be operated by dedicated diesel engine or by a alternative power supply source. Actually, in NFPA, they do not allow the alternative power source. But in our country, which is very peculiar, almost all industry have their own power supply. Even almost all big housing facility or almost all shopping center, they have their own power supply. That is very different to the other cities of the world. So in BNBC especially, we write this word by an alternative power source. NFPSA is a diesel engine directly coupled with diesel engine, but in BNBC it is added in a special word. If you have another source, you can also use another pump with electrical power. But you need two pumps at the same time. One is running, another is standby. Quality of the pump assembly shall comply with the specification of the International Registry of Fire. How it is specified, I can show you now. For pump, we need a maximum reliability and additional outlet pressure, which is not a general type of pump. So general type of pump normally is designed with maximum efficiency economy, but fire pump is designed with the maximum reliability and additional outlet. You be careful about the additional outlet. I will show you what is the additional outlet. This is the characteristics of a fire pump. This additional, that means this is the, if I designed a fire pump with a nominal flow of 100, the pump should work 150% flow with a pressure not less than 65% of your design. So if your design is 100, then when the flow rate is 150%, then the pump should work perfectly. And at the zero pressure, zero flow, the pump must supply, the pump must create 140% than the design criteria. This is the very specialty of the fire pump. At zero flow, the pressure does not exceed 100 times of the nominal value. At 1.5 nominal flow rate, pressure drop 65 point of the nominal value. Speed in this suction line should be such that it will be less than 3 meters per second, because if you increase this velocity, there will be chance of stagnation and vortex formation. If there is a vortex in the suction line, you may lose flow rate. Mountings of the bearing of a fire pump should be such that it can run at least 5,000 hours for its service life. This is as per NFPA 20. So these are the criteria. Then we have some other extra criteria for fire pump. If you procure a fire pump and if you like to test the pump, this is the criteria it must fulfill. That means when you test a fire pump after procurement, then you test the must match with this line. That means it should be, if rated capacity is 40, then the maximum variation with it is like it should be 56 and the value should be 26. The minimum of 65% rated pressure at 100% rated. This is the required criteria. But when we test, a fire pump can supply the system, fire pump test results not less than 95% of the flow rate. So that maximum variation will be allowed if it is 95% of the flow rate, or if it match with the pump nameplate specification. To make it clear again with these ratings, I am showing another curve. If the nameplate curve is the red one, if you are testing, if it is the black one, the maximum variation will be this. If this variation is this, then we can accept this fire pump is acceptable. So this type of variation from the design criteria of the fire pump and actual field test of the fire pump is within this limit, then we will accept this as a fire pump. And you have to remember that every year you should need to test the fire pump and ensure this curve, the maximum variation, maximum flow rate of the variation. If it is beyond that, you are not ensuring the condition applied for a fire pump. So there are some capacity table for a fire pump which is available in the market. From this available size, you have to choose your capacity of the pump. So depending on your requirement of your occupancy, so you have to choose the fire pump. It may be around 250 gallon, or it may be 300 gallon or 400 or elsewhere. And corresponding to this fire pump, you need this type of pipe with the connected with the pump. In the very long distance, the pipe diameter will change, but a very at the entry and the discharge, you have to give this size of pipe with the pump. Normally, this is the maximum size we use in a fire pump. If it is more than that, you have to use more than one pipe. If your occupancy is so big, or it is designed that way, building is different type of building. So while designing this hydrant system, you have to design your flow rate, you have to design your pressure. Actually, a pump is based on the pressure and the capacity flow rate. So whatever you have shown, you understand your flow rate, but you have to calculate how much pressure you need, how much pressure you were designing for your pump. So your pump design pressure should be as follows. Actually, there is a pressure which at the nozzle outlet, which I showed before, and there is friction loss from pump outlet to the end of the nozzle peak. The pipe you need to design to for the required distance, cover distance and height. There is some friction loss within the pipe, within the valves, within the bends. So all together you have to calculate the friction loss, and you have to cover a certain height, that is called elevation. So you have to calculate what is the elevation. Actually, for 1 psi you have one feet of height, you have half psi of pressure loss. For every 1 feet or every 2 feet, you have 1 psi of pressure loss. That is the force loss for elevation. But for friction loss, you have mathematical calculation, depends on different variety of things. So that I will show it just for idea, not a detail. For you detail, you have need to calculate a lot of things. So this is the friction loss. There is a coefficient of friction that will be taken from the chart, body chart, and Q is the flow, and L is the equivalent length. I am saying the equivalent length. Equivalent means distance length, and if you have a bend, if every bend has some equivalent in the table, for every valve you have equivalent length. So you have to sum up all these length for hose, length for pipe, length for valves, length for bends. For everything you have to calculate what is the equivalent length. And then you have to calculate for the friction loss. There is a table for the C, that is the coefficient chart. So this is only for this size of hose, but if you have different size of hose, so you have to take other values from that. So all taking together, you can calculate the friction loss. So if you can the friction loss, you know your nozzle pressure, you know your elevation, so you can calculate your pump discharge pressure. So you know your flow rate, you know your pressure. Now you can design your pump, you can design your system. So there are some other points also for calculating. So just a few points which you can remember for your requirement. Actually, the hydrant system is used by the fireman or inmate, which is available during fire. But if you are in occupancy, you have to handle that. You cannot handle the firefighter hose system. The firefighter, they are trained. They use a hose which is 2 meter, more than 2-inch diameter. That needs very special capacity. So Normally, there are three classes of system. One we call class 1 system that will be handled by the inmate or in the firefight both. There is a class 2 system which is only for the inmate, which is first aid system, which will be used the inhabitants of the occupancy, and there is class 3 system will be used by the firemen only. So, so according to your design, it can be used by either trained person or either fireman personnel. So normally trained person use a hose which is 1 inch in the real form or 1.5 in the hose form. That will be used by the trained or amateurs. And firefighter normally use the 2 inch or 2.5 inch hose system. The amount provided the flow is given in the table. A standpipe shall be interconnected through the check valves to prevent recirculation. You show the typical diagram. The minimum pressure at the outlet shall be 300 if it is the 2 inch millimeter, 50 millimeter diameter hose. If it is 200, it is 30 millimeter diameter. If it is sprinkler, it is 600 kilopascal. You have to remember while you design the maximum pressure at any point of the system shall not exceed this 10 kilopascal. This all your valve, all your line will be designed with the maximum pressure. This regulating valve need if your outlet pressure exceeds 700. So your outlet pressure should not be more than that. If it is more than that, you have to put extra regulating valve to keep it less than 700. Diameter of the standpipe pump's capacity shall comply with the flow and pressure requirement at the topmost heighted point. So we have to design with the basic theme, basic, and the basic assumption is that my pressure will be at the topmost heighted system will be my basic starting. Then from that we calculate all other parameters. The stored fire water shall not be used for other purpose. The groundwater storage tank be easily accessible to fire engine. The standpipe shall be located intermediate stair landing or vestibule or nearby in non-combustible enclosure. It is normally if there be a position sometimes the stair landing from one to another, the distance between two standpipe is more than the double of a standpipe. Actually, a hose pipe, the maximum length is 30 meter or it may be 100 feet. If you have two stair landing at a distance of more than 200 feet, then you must have an intermediate position where you can put your another location for spray system. You have to design in that way so that every area of the occupancy can be covered, can be reached by your spray nozzle or fire nozzle, because the nozzle has a limiting length that is about 30 meter. So if your distance from the stair landing is more than that, so you have to give some position so that you have need some extra hose cabinet intermediate position. Then hose cabinet should not be at a height more than 1.5 meter for ease of handling and inspection. There should be CMS connection in the location from the outside street. I have told before. The system shall provide adequate drainage piping to discharge under pressure, because sometimes you need to test the system. So always you have to have a drainage system so that if required, you can test the system. So you need some drainage system in addition to these all the things. Similar, these are some other design of a hydrant system. So a hydrant system can be wet riser or it can be as a downcomer, and you may have some high velocity projector. Wet riser means you have your pipe which is always filled up with water. So at any time you can have water for your fighting at the time of fire event. So sometimes if you have the downcomer, it is in the same language, that is the this same pipe, it is fed from the gravity tank, rooftop gravity tank. It is a different name, but it is again is a riser. Then high velocity water spray, there is you may have some design so that you need some high velocity water spray system. In that case, you need some special spray nozzle so that you can spray your area with small droplets at a high velocity. So you need some high pressure and you need some special nozzle to spray the area. You understand, the much more you can spray with a small size of particle, the more area you can cover, the more effectiveness will take place for ignition your fire. So the finest is the particle, the more area with small water you can cover, and the more effective the fighting system. There is another one which we call the water mist system technology. This is a very special type of water spraying system with a high pressure and very special nozzle. The nozzle will atomize the mist. Actually, with the system, you need some air pressure or nitrogen pressure so that the air will create the atomized water so fine that it will create fog or mist, so that in a 1 liter of water you may have more than 22 billion of droplets. So 1 liter creating more than 20 billion droplets, you can understand how fine it is. It's fog. The size of the particle is around 10 to 15 micron. So in that case, by using this water, you can fight class A, class B, class C fire also. So in addition to the A, you can use water. For the computer, you can use it. For the flammable liquid, you can use it for all the electric system. This is the very, very effective system and very safe system because it is using non-toxic material, that is the water. Almost all gaseous halon, all other gas system use those gases, those chemicals which is toxic. This is very dangerous. Who spread that? Who will be reared that? So if we can use water mist for our extinguishing system, that is always safe. So it is safe for electricity, electrical equipment, computer. It is safe for type of fire. It is safe for almost all type of fire except material fire. So this is very safe. So normally it is used by the system is very effective. So there is sometimes we need to cool our protection wall. If you think our glass wall, if its temperature is very high, then we have to drench the wall. For drenching, we use a drenching system that is a different type of sprinkler system. It is nothing. It is a special type of drenching system which will be kept in certain area, that if you like to cool some wall, if you like to cool some tank, as for example, if we have a generator, if we have a big size of fuel reservoir, to control the temperature of the fuel reservoir, sometimes you need to cool the surface of the liquid fuel tank. In that case, we use the denser. So that is mainly to not the extinguishing, that is mainly to the control of the temperature of the surface which you prevailing in our occupancy. So denser is mainly to control the temperature of the surfaces as you need, not to extinguish any fire. So that we call the drencher. And there is another one system that is always, this is also a part of a hydrogen system, but that is dry. When if we put water always in the pipe, particularly like our country, there will be always corrosion. Water always have some type amount of oxygen with it. It may be 8 to 15% of oxygen in the water. So due to the presence of oxygen, always the pipe inside is corrode, the supplying system will corrode. So if you can keep it dry, then life will be, the pipe will be longer, life of the system will be longer, but there will be a time gap to start and finish. So if you can properly handle, a dry system can be worked, but it is very good for longer life, very long life. Normally, a hydro system does not last very much. Within 10 or 15 years, you have to see, you can see the most of the part valves and the engine they are corroded, particularly in our country. So if you use dry system, then it will last much longer. So you have to be careful in dry rising system. Now I like to talk something about the sprinkler system. Actually, sprinkler system is nothing. It is a special modification of the hydrant system. So, in spite of the hose supply hose and its nozzle, we need a network of pipes with different arrangement. So every location of the occupancies, there will be a supply water line and a sprinkler nozzle. It's all called a sprinkler head. At a certain temperature of the sprinkler head, that will burst, because that there is a material which will melt at a certain temperature. So at a certain pressure, due to the certain pressure of the water inside the nozzle head, it will come out. The head will open up, and it will spray water to the area where the sprinkler head is positioned. So what this head will be positioned in such a way, at a height or at a different angle, depending on your area you like to cover, and it will be connected by different size of pipe, different size bigness with the number of, with the size of the pipe. There is a number of head which will cover by a required amount of water. I will show you the table where you can see the size of the diameter, that is the diameter of the pipe, how much sprinkler head you can install depending on this requirement. If if your area require 10 sprinkler head, you have to choose that type of that diameter pipe. If between number of sprinkler head, you have to choose the diameter, and you have to connect with the water with a pressure which will continuously remain inside the pipe, and that pipe will be maintained initially by jockey pump. When any occurrence happened, then this jockey pump will give signal to the main pump, or your sprinkler will give the signal to the main pump, and that will start automatically, and you will find delivery of water to the every sprinkler head. The pipe scheduling size of the sprinkler for different uses may be in the according to the table. I will show you the table. Each sprinkler shape serve excuse me, a maximum ceiling area specified in the table. So for your sprinkler head, there is a number of the sprinkler head. So depending on the number of the size of the design of the manufacturer, it will give cover a definite area of the ceiling area. So depending on the design, it will cover that one. Water supplying pipe and fitting for the sprinkler shall be conformed to the standard accordance with these days. The sprinkler piping system shall be provided with adequate support, that is the supporting of the pipe network, and each pipe will be hanged from a hanger. The hanger should be supported with an extra load, so that in the event of any accident or any natural calamities, the hanger will remain intact. This is the table. There is some material, copper tube, steel tube. That is the standard. We are making that. So that is different standard pipes. This is the fittings. This is the pipes. So depending on your requirement, so you will choose which one you like. the type of the material, if you varies the type of material, the cost will be vary. So depending your requirement, depending your capacity, depending your design, you will choose the pipe and the pipe fittings. This will give you the pipe size and the number of sprinkler head you can fit. If your pipe is 1 inch, then you can fit two or one sprinkler for at a pipe. So if you increase the diameter of the pipe, your number of sprinkler will be more. So if you have to design in that way, actually that when you design the network, you have a main supply water line. From the main line, you have the branching of the smaller diameter. From the branching, you will select how much sprinkler head you can accommodate according to your requirement. So you can see that you can that if it is 4 inch, there is no limit. You can put whatever you like for the. So accordingly, you have to design your network or pipe network, water supply pipe network, and the sprinkler head. This is it. I think this is the repeat of the table. So this is the area coverage of a sprinkler head. Actually, different manufacturer has different types. So, but this is a general value. But so normally for a sprinkler head, it varies. The flow rate, the area coverage is almost 100 to 200. It is almost 100 to 200. So this is the lowest value 100. This is the highest value is 250. Actually, the distance between one head to another, next one is 15 meter. So if you think of the 15 feet, 15 feet distance. So if you think the average square, that is covered by a single sprinkler. So this is the nominal value, but if you like to put some design factor or safety factor, you can curtail it with 10%, 20%. But in our country, in last few years, in different garments industry, we have been visited. Mostly they design with roughly 150 to 100 to 150. It is too high density. Actually, the high density does not give you extra. It gives some extra money, extra design, but it does not give extra safety because it is designed, whatever the design value, it should be within the limit of the design value. So if you can use 10%, 20% as a safety factor. You should not make it 100% safety factor in no case. But the way they designed some of the design, they use less than, in some cases I found that less than 100 also they give it for the ordinary hazard, which should be the more than you see for ordinary hazard it is 130, roughly 130. So there is no point of giving more than less than 100 in that case. But actually, somebody designed it that way to make it oversure. No, it should not be. But so you see that normally the variation of from the extra hazard to very low is 100 to 5 for a sprinkler. This is a piping material. So if you have a copper type of piping material, or you can use depending on the STM value. So your hydrogen system should be connected from something, from some. There shall be CMS connection to sprinkler system in a building. All risers shall be connected through a gate valve with a main of size equal to that largest reservoir. The sprinkler system shall be provided with adequate drainage arrangement. The drainage pipe shall not discharge into this sanitary sewer. All control valves and fittings shall be able to withstand the pressure, that is the maximum pressure for which you design your system. We had some idea about the inspection, testing, maintenance. Actually, this type of system, particularly when the system is automatic, your maintenance must be very, very frequent. If it is not, you will lose your reliability. Actually, there are some statistical data for America or UK. That is not very convincing. NFPA have some data for American standards. Their efficiency is not very high because the regular maintenance is not do that much, so that when you actually require that, it does not work perfectly. In Bangladesh, maintenance is always neglected. So if you do not maintain your system at the time of event, you will not find any working condition, so you lose your reliability of the system. So all piping equipment shall be inspected for satisfactory support in accordance with this part of this code and protection from the damage and corrosion. All outlets shall be free from obstruction. So you have to maintain this very regularly, very regularly. You have to inspect. There is some inspection conditions as written that. I am not giving a detail of that. Maintain the system shall be maintained for safe operation condition and tested at least once a year. So you have to test every year. That's why we need a very effective drainage system for testing the system. So testing the fire protection plumbing system or part thereof shall be tested approved. So you need some approval from some authority. Testing system. The hydrant pipe shall be hydraulically tested at a pressure 1400 kilopascal or 150% of working pressure, whichever is the higher, for 2 hours without any leakage at any point. The system shall also be tested for the required flow at the highest outlet. So this is the condition of testing a standpipe system. So you have to think about the pressure and the total duration of the test and the observation you have to make. There will be no leakage. So these three has to be maintained, and you have to test at the furthest point outlet so that the flow is maintained there. This is the test for standpipe system. The testing for sprinkler system. The system shall be tested at least 2 hours for a pressure of 100 kilopascal or 350 kilopascal in excess of nominal working pressure, when normal working pressure will be more than 650. If you understand that 650 and 350 is 1000, so whatever you say is 1000 kilopascal is the normal working pressure, but you may have some special case. So in that case, you have to test little bit higher, that is the adding 350 with your working pressure. The system shall also be tested for required flow at a highest outlet. So you have to test. In sometimes a sprinkler is tested by putting a hot flame on a sprinkler and give you a fused system, and then measure all the parameters. And that's all about the hydrogen system. Now you have to talk some other system which you need to understand for your special design, special requirement. That is the other than water. There are different types of fixed installation. This is required particularly for different chemicals, different areas, different occupancy. You need to put a fixed system because water is not good for those systems. If you think about your computer room, if you do not want to have water mist, so you need some fixed system to be installed there. If you think about your generator, if you are similar type of electricity, your transformer room, if you don't have water mist system, then you need some other system. So those system can be divided into, it is the centrally fixed or locally fixed. If it can be centrally fixed, the system can be of foam. It can be a central system. It can cover a zone or it can be a local area. So there is some pipe connection, and then system will be foam installation or vaporous liquid installation or dry powder installation or gaseous installation or dry chemical installation or wet chemical installation. You can take a different type of installation. Then you have your pressurizing system, you have your piping circuit system, so you have your alarm system. So in the event of fire, the alarm will first give you this alarm so that all people will go outside the system. After that, the system will operate. If people is there, if it starts immediately with this alarm, immediate with the fire initiation, the people who is working around that, their life will be very endangered, because all the systems are toxic. Because not only toxic, actually they prevent oxygen to move around that. Actually they restrict, they not on the hot surface, they restrict all the of the oxygen also. So before initiating of this system, there must be have an alarm system which will give alarm first, a distinct alarm, so that people understand that they are extinguishing system will start and they have to leave the space as fast as possible, then the system will operate. So there is some very special idea for the different system. Foam extinguishing system shall be of approved type, shall be installed in accordance with the specification of the manufacturer. A foam extinguishing system shall be automatically actuated during a fire with provision of manual actuation. Warning sign and the discharge alarm shall be provided. The system provides protection of boiler room and other oil and other hazardous storage. The different type of foam industrials are there. So you have different companies, different manufacturer design in different way. So these are all market available proper extinguishing system. These are effective. These are but you have to use it with a very good knowledge even and with practice. There are other fixed systems, the vaporizing liquids installation, dry powder installation. These are also there are different criteria. So if you read this system, these things, you can understand this. So these are all centrally fixed gaseous. So there is some localized fish installation. This is a containerized extinguishing agent are available in different shapes and size to be placed in different locations, such as at the top of the cooker, in the kitchen, in the electric box, electric areas, so that at the time of fire, this container will be heated and burst, and it will release some extinguishing agent and extinguish the fire. These are some locally agent in Bangladesh. Sometimes we find there is a ball or some granite type thing. It was imported, and sometimes it was tested, and some of them were found good, some were not, was found not sufficient, maybe for different reasons, but most of them were working properly. But you have to be careful about their performance, because the location and the RAJUK temperature should be such that it will be positioned in the proper way. If you think about the kitchen, if you don't put it in a proper way where the flame will be maximum, it will not start at this particular time. Then we have some idea. I like to give some idea about the portable fire extinguisher. You know, it is abundantly available in Bangladesh, almost all area of Bangladesh. There are different size, different types, different qualities, different manufacturers, and it is portable and it is used. It is very handy. Actually, you know, when the flame is on the fire is very small. So if you have a small extinguishing agent, you can control it very easily. And if you can control it very easily, the fire never goes up. You know, almost that is actually after initiating a fire within 3, 4, 5 minutes, grows up, and at some time it flash over. When it flash over, it's beyond our control. So you have to try as fast as possible to handle the fire, and this fire is normally handled by using this portable fire extinguisher. So if you are very careful in the fire extinguisher, you can control fire in your premises. But you have to be very careful about your type of fire. First thing. Second thing is the way you are using it. Third thing is the whether your portable fire extinguisher is working fine. Actually, it has to be regularly maintained. Every time you have to check and keep it working condition, because with time, though you put it very perfectly condition, with time it becomes unusable because it loses quality, it loses performance criteria. So you have to test very gradually, very accurately, very time, and you have to position and keep the portable extinguisher in a place that which will be always in front of the users. So there are different type of extinguishers which we call A, B, C, D, K, depending on the type of fire. So there is a table, you can see depending on what is the portable extinguisher type and what you can extinguish. So if you familiar with this, then you can fight. If you are not familiar, don't try to fight with the fire. So only the trained person should fight this type of fire. And each training is very simple. If you like, you get training and you use this. So on your container, this type of marking is written always there, either A, B, C, D, or this type of picture. From this picture, you have to understand what is the material you can extinguish, what you cannot. So you have to be very careful about this A, B, C, D, or this pictogram. So in your bottle, there will be some. This is different type of container. This is a water, pressurized water. You can use it. This is carbon dioxide. This is a horn. So you can use that. This is ABC. It is written on ABC. It is K type. There is other also K type. There is ABC. There is DC. There is BC. So depending on the ABC, this figure you have to choose. In Bangladesh BSTI have a rule. Depending on the chemical, there are different color of this portable extinguisher, but we are not using this color. Actually, according to their rule, the carbon dioxide should be this cylinder should be black, so that by choosing the color, you can understand it is carbon dioxide. But normally, people do not used to with this color type of. So almost all everywhere, almost it is red or it is same thing, same color. But BSTI have a color code. That is our standard code, a standard color. But we are not habituated with the color. So, but if you see sometimes the color of the cylinder is different, that means that color indicates what is the content. If you see a black color of cylinder, that means it is with the carbon dioxide. You should remember one another thing, though I am showing here is a carbon dioxide. Actually, there is a Montreal Protocol in 2018. Carbon dioxide should not be stored in that way. So it not yet Bangladesh, but all over the country, world, now it is a banned item. You should not use carbon dioxide because it is a greenhouse gas. So that's all about the fire extinguishing. I'd like to say something a little bit about the tall building. Though Bangladesh have, so far I know there is no tall building. Maybe there is someone. High-rise building exceeding 80 meter. So about 25, roughly 25 story building, 25 story building. Bangladesh have one or two more than that. That is the tall building. So the quantity, source, and mode of water supply in tall buildings shall be according to the act. It's the same time you saw that one. But there is in high-rise building, fittings equipment for firefighting may be subject to excessive pressure. So the pressure limit which I have shown before will be a little bit different for the high-rise building, tall building. Sorry, this is for tall building. Pressure on firefighting equipment in tall building shall be reduced by dividing the building into different zones. So in that case, if you like to design, we have to divide the zones. I will show you a figure so that you will understand how it can be zonized. Separate automatic farm or combination of the tank and automatic pump shall be installed for supply water to the firefighting equipment in each zones. This is an idea of the fire pump. If up to a certain height, you will as designed as I described before. For the high rise one, you need another to cascading system. There's one pump will deliver it water to a reservoir here, then another pump will be used for the secondary one. So by cascading the system, you can go the tall building. So you need some extra pump, extra area, so that by cascading the system, you can go for a tall building to reduce the effect of very high pressure within the supply line. And that's all about the firefighting standard system. So now I'd like to talk something little bit about fire detection alarm system. Fire in a building behaves differently from fire outdoors, as you know. High temperature toxic is rise to the ceiling and spread outwards and downwards. A smoke will pass through any space or opening. Early detection, rapid evacuation are very essential. So you know these few words actually. Smoke is made of carbon dioxide, carbon monoxide, and other toxic gas. All are very dangerous for your life. Within a or 2 minutes, if you inhale carbon monoxide or carbon dioxide itself with either a little bit higher concentration, initially you will lose your sense, and depending on this time, you may die in a few minutes, not more than 2 or 3 minutes. So in some cases, if the concentration is more than 50 or 20% in the room, you will die immediately. You will die immediately, not with the toxic gas, by only carbon monoxide, carbon dioxide. So but unfortunately, toxic smoke give you some irritants, but carbon dioxide cannot not give you irritants. So you will not feel, you will not think that you are smelling a very dangerous gas. So you are inhaling carbon dioxide, carbon monoxide. You will not feel it. You will not feel irritant, but you will lose your conscience. You will lose your life very quickly within few. That means 3-4 minutes, 2-3-4 minutes, depending on the concentration. It is so dangerous, carbon monoxide and carbon dioxide also. So actually, in any fire event, people normally die after losing sense initially, and then by burning. Initially, they lose their sense due to the smoke, due to the carbon monoxide, due to the carbon dioxide. They lose initially their sense, and finally they cannot come out. So when in the event of fire, you have to come out from this area within minutes. Particularly, it will vary. You know, a smoke from one foot initially move very fast. It is roughly 3 meters per second, 2 to 3 meters per second. But if people can move with more than faster, people can walk a normal walk, we can move 5 meters per second. If we walk, we can move faster. We are always faster than the smoke flow naturally. If can walk, if naturally a smoke flow after burning, you can move faster that one. So you have to move faster than the smoke move, so that smoke will not accumulate to your area, so that you can easily evacuate. Be sure you should walk within 2-3 minutes from the area of incidents. Otherwise, you cannot feel it. You cannot see smoke. You can see smoke when it is with the carbon particle, but in normally a smoke with carbon monoxide, a smoke with carbon dioxide, you cannot see. You cannot feel irritant. So, but it will creating some problem in yourself. So be careful with this smoke, whether you see or not see. If there is a fire, there is some propagation of carbon monoxide, carbon dioxide. So be sure that you should evacuate with a few minutes. Don't delay any time. So you have to need detection of fire as quickly as possible. So you have to put your detector in such a way that at the just initiating of this flame or smoke, it will be detected. So you have to be very careful about the detection. Don't depend on the on. Sometimes you cannot you may not see, but whenever you see, do it quickly. Fire detection should always it is best if you can be done by human surveillance. If any area, particularly I like to say, in the shearing area of a garment factory, there is a lot of people in there. They can get that human surveillance is much better than any detection system, because human surveillance has always good. They can see the flame or they can see the smoke very quickly. So human surveillance is so in the area where human surveillance is not possible. So you must put some automatic detection system. There are different type of automatic system. So I will come to it. Actually, when there is a fire, what will happen? There will be some smoke. There will be some heat. There will be some ions which will generate. So a smoke is a colorful detection. There is some ion which has not color. There is some gaseous detection, and there will be a detection of flame, and there is detection of heat. So by detecting the heat or its gas or a smoke or ion, or by detecting the flame, so we have three different type of thing. The one is detection of heat, detection of smoke, that means as ion ionizing anything is we call it a smoke, and last thing is the video or the color of the flame. That we have with these three types of detection system is there. So depending on your area, you have to choose which one you like. But there is no system which will detect everything. So you have to see, there is no system. A single system cannot detect everything. So you need different system for different area, or you need multiple system all together at a time. For detail, I should go the appendix for in the appendix C, detailed guidelines for selection and setting of the fire detection system. I will explain that one. First, I like to talk something little bit of fire alarm system, because after detection, all human being will be alert about the sensor. There is incident of fire. In the incident of fire, panic management shall be the prime concern for a successful location, delayed aggression or evacuation. So that you have to manage the panic situation. So for management of panic, you need some rule, need some practice. The practice that is a practice you should do drill sometimes, and for the other thing you have to give them knowledge so that they do not be panic. So for successful relocation and delayed egress or evacuation, you should not be panic. Activation of alarm shall be sequential or compatible with all the design scenario. A general announcement of fire shall be done initially. During the, if it is a multi-story building, all floors should not be signaled at a time. In that case, all people will come together. That will create a problem. Actually, initially, first you have to evacuate the room where the level where the fire is incident, and the just higher level, not the level, the affected level, and just above the higher level. These two levels should be first initially informed, and they should be activated. They should be initiated for evacuation. So you have to give an alarm sequentially, and you have to decide accordingly, and then send you. Person responsible for the evacuation shall be alert through a password. So all persons should be alert first, so that they can take steps. As per design scenario, a systematic evacuation protocol shall be developed for relocation, delay aggression, immediate evacuation. The alarm system allows the application of alarm signal to one or more zones at the same time, shall allow voice paging to the other zones or in any combination. Activation of fire extinguishing system shall have a supervisory alarm. An automatic extinguishing system capable of discharging other than the water extinguishing agent shall be direct distinct alarm system. So, these are the different type of alarm system. So there are three types of alarm system normally. This is audible alarm, this is visual alarm, and the display alarm. Normally we know that there is an audible, but at the same time there are some person they have a problem with the audible. They should be given a alarm visually so that they can see the light, different type of light that is we are normally show in the ambulance. There is a light blinking. So by doing this type of visual alarm and some type of display also can be graphical or textual can come on the monitor of the TV or anything any display. So people see the alarm so that they can activate, they can initiate the program. So little bit about the appendix. Selection of site for detection. Actually, choose of detection is actually we have to choose a smoke detector where temperature is high. We can choose heat detector where is dust is more. So by selecting this type of criteria, we can select whether you use heat detector or smoke detector. Another thing is when there is a line of sight advantage, only in that case we can use the flame detector. Actually, for flame detector, you need some line of sight problem. This is an example of a heat detector. Point or spot type of heat detectors are found. Both type of heat detector, they are heat sensitive element. There is there, so it can be fixed type of temperature detector or a rate of rise of heat detector. So heat can be detected in two way: the temperature or the rate of rise of temperature. By doing the reading of the temperature rise, you can this system can detect. And if there is the area is dusty or moist, or in that area we use a heat detector. This is normally very safe to detect heat. So these are the area where heat detector can be used in the garage, in the kitchen. So normally these are the area where heat detector can be used. This is a flame detector. Actually, this is not very convenient where the line of sight of is not used. If line of sight can be the area, then it is very convenient. But it is a very costly thing. It is not very costly thing. It will detect the flame light. So you need some line of sight position. Actually, normally the line of sight is not very available. So this is an smoke detector. This is very commonly used, but this is used. But in our country, due to the dust, moisture, it gives normally it is very difficult to have proper signal. It gives some false alarm, false signal. So you have to be very careful with this. So it is setting, and normally it is very difficult. Another thing is in our country there is always we keep our door windows open, and we always particularly in garments factory we use a lot of exhaust fans. So there is a lot of flow of air. So as there is a flow of air, any smoke coming from a spot area that is easily diluted. So it is very difficult to get signal from this type of smoke detector. But it is normally used, but its proper detection is always hampered. Or sometimes due to the dust area, dust deposition in our country, there is always some false alarm. So sometimes it is equipped with some special tube to avoid this type of thing. But its efficiency, it is prone to have false alarm. It is prone to have uh, wrong indication visible. So for smoke detector, particularly in our country where we are habituated with the very natural air velocity, naturally air flow, and naturally we always have our room with a very high velocity ceiling fan below. In that case, there is every chance for wrong detection. So you have to be careful about fitting this smoke detector. Their location is very. So a smoke detector not, it can smoke or it can be with ionization chamber. Actually, a smoke is a carbon particle. Normally we use it in black color, but if it is ionization, actually from any flame, there's some ion forms, and if this ion goes to the close of the smoke detector, it can detect again. So there is always chance of wrong detection. So again, a chemically sensitive smoke detector. Actually, if I like to detect carbon monoxide, carbon dioxide, particularly in the garage, but in the underground floors, there is accumulation carbon monoxide. For detecting this deposition of accumulation of carbon monoxide or other combustible other product, then you need some detection of the chemical sensitive detection. These detection are chemically sensitive, so we can detect this detector. This is the site setting of the detector. Actually, how location of the detection, there are a lot of combination of areas. Actually, all manufacturers have their guidelines, so how the detection went, but you have to be careful about the building beams, columns, or shading, staircase, various form of overheading, so partition wall. So depending on this, you have to decide what is the best location for a setting. So this you have to follow the guidelines from the manufacturer. Actually, every manufacturer have their own suggestions, but you have to think about your egress system, shape, particularly on a stair or lift. For these are the area you put some special detector. So there is every chance that the exhaust air flow, cooling air, they create obstruction for detection of this. So you have to be very careful with this, keeping this detector at the proper location. Now I like to finish this chapter part of the part that is chapter 3. Now I like to start with the chapter 5, which will give you some requirement for the fire detection extinguishing system. So this is some specific requirement which you will give put in this area. But you have to remember specific requirements need a specific requirement for the occupancy. So you have to first define how a occupancy would build up. If it is that only that condition, you have to accept this recommendation. You change the condition, you have to make your own performance-based design. I can repeat this one. Please remember that. As for example, your building is type 1A, it is 4 hour. If your building have a class of material class 1 or class A, then these are the following suggestions that you can meet. If it is different of that, if your combination is different, then all your building, all your occupancy has to be performance based. So here, whatever I give as a specific requirement is assume that it is type 1A and your class of material is class A or class 1, whatever you say. So with this basic assumption, I am coming to some points. In this chapter is to reduce the probability of the injury or death from the fire structure failure or confinement extinguish evacuation. Provision of this structure shall be considered as a minimum requirement. So if you like, you can give more. Passive and active performance-based fire protection shall be designed for all the type of active design, but if it is a particular type, then we'll give some suggestion. Passive includes the arrangement of building. Active means detection, alarm, extinguishing devices and equipments. So we have talked already about the passive system a little bit more. Then we have some built-in machinery, equipments. We have talked that. So now I will talk something for performance-based design. What is performance design means? Actually, for performance design, we have three types of scenario. First is building class fire resistant rating. Then you have to ensure what type of class of building you are designing. That means on what type of material you are using for your every element of this structure. So based on this data, you have to be ensure your building classification and your registered rating, because all your building internal structure is based on these two. So you have to be take data for the following. Number one, all surface finish material, joint of the structural member, all slabs, roof slabs, joint between slabs, all exterior walls, all interior walls, partition, suspending ceilings, everything. So you have to need the data for all structural. These are all structural elements, so that you can classify your building. You can buy what type of building you like to design. So first you have to design this term, the all. Second scenario will be your occupancy specification, because depending your occupancy, you have different type of combination of fire extinguishing system and fire extinguishing passive fighting system. You have already discussed. So you have to be very careful about your occupancy. Not only the occupancy, little bit more, the occupant activities, number of and location of the occupants, room size, number of control areas, finishing and contents, fuel properties. Fuel properties of what? What type of fuel are available? The fuel is a class of materials and ignition source, ventilation condition, and fire item ignition and its location. So you have to assume where your fire can initiate. What is the location of that initiation? You have to imagine. You have to find that area, that location, which is critical for your occupancy, for your building. So in the second scenario, you have to find out the location and the area which is much prone to ignition of fire, and how this fire can propagate depending on the type of material, and what is the total volume of fire load you have to control by your design. Third thing is the combination of all of these, the largest possible fuel load. So you have to calculate the largest possible fuel load, the total fuel load of the area, or in a compartmentation, or in a zone. What is the largest possible fuel load? If there is event of fire, this is a slow developing fire, and if it is slow floating fire, what are the proximities, or what is the high from this low floating area? What is the distance of the high occupancy area? So you have to find your the critical area in respect to your fire, in respect of your occupancy. So and the proximity is this two. You have to find this one. A concealed space adjacent to the largest occupancy room having highest number of occupant without either detection system or suppression system. So your system you can design in such a way that there is no detection, there is no fire system. You have to imagine that one. You have a room which is highly occupied, and the system don't have any detection, and the system don't have any fire system. And what will happen? Keeping that idea in mind, you have to think your building design, buildings partition, your passive fighting system. Again, you have to think about your ultra fast developing fire in the main exit area, but reduction in the number of available means of egress. So you have thinking that you have a ultra developing, fast developing, ultra developing area. That means there is a deflagration. Deflagration means a flame, a fire which is moving less than sound velocity but more than our normal velocity. So it varies, but the pressure variation is about zero point 0.5 psi. So with this deflagration a fire can move faster than we move. So with assuming this thing, with assuming your egress system, you have to design your building your occupancies. You have to think about an unoccupied room or other area from where a fire can start. So you have to think also the a room which is not occupied. As for example, it can be a storeroom, it can be an unattended room. You have to think about that area where fire can start. Then the reliability and the degree of design performance for the fire detection and protection system. Then you have to think about the reliability. So you have to think about the reliability your detection system. Actually, all detection system does not rely. So you have to think about the how percentage it is reliable. It is 50%, 60%, 70%. So depending on the reliability, you have to put an extra detection system. You have to design with the safety to protect the system. The scenario shall not be considered a room or a space or building where fire detection, protection system or any independent features are absent. So the scenario shall not be considered for a room or a space of a building where fire detection and protection system or any independent features are absent. So we will not consider this one. We will think about this other detection system, but we will not think about this. So considering these all the things, then you have to design performance. We have to design. So you have to again to the idea of it. You have to for performance design. You have to design your occupancy, your load, your rooms. You have to find your critical one. Why what is critical? As per depending on the occupancy, as per depending on your ignition source. Then you have to find design your building structure. Every element, which one can, how much time you will get and how much fire safety you can like to give all and every part of a structure element. It can be anything. It can be any joints or slabs or partition or everything. You have to design all the things. Then you have to combine all the things and taking all fuel load, all rooms, and taking the critical condition. You have to design your performance-based detection and performance-based extinguishing system. This is a little bit idea about the performance-based design system. Now a fire protection plan. Actually, when you need to put a design a building, you have to submit a fire protection plan. A building or a part thereof must have a fire protection plan for the following cases. So there are some special case. Actually, if you have very small building, a small house, you do not need a fire protection plan. But if you have a high-rise building, you need a fire protection plan. And other things, if you have a G, H, J, K, M type of occupancy, and if is a certain area is certain more than a certain area, then you need a fire protection system. A3 occupancy containing 330 or more dwelling unit, A4, A5 having gross floor area of the building more than a, you do not need a fire protection system. Part of a building used as a mercantile assembly station or healthcare, you need no fire protection system. But if you have more than that area, you need a fire protection system. Having gross floor area of the building over 330 meters square, you need a fire protection system. Whenever you alteration a building or a partition of thereof, you need a fire protection plan for the following cases. What is present in a fire protection system? In a fire protection system, you have to give this following information: building address, height of the meter, occupancy classification, detailed occupant load, and you have to give a floor plan showing all floors, exits, corridors, partition serving for fire separation in the compartment, location or rating of the required enclosure, rating of the required windowless stair with pressurization, exit discharge, location of front space, including streets, width of the everything plots. So in your plan, you have to these all of the details. So initially, you have to give information about the buildings and about the design, and then you have to give the description of the safety system features, which includes communication system, alarm system, detection system, location of fire command station, elevator recall, emergency lighting and power, extinguishing equipment, compartmentalization, horizontal exit, mechanical ventilation or air conditioning, smoke control system, equipment. Furnishing type of materials, place of assemblies, fire department access, other system required or voluntary to be installed. So these are all the parameters you have to give in fire protection system. Finally, two persons has to design. One, the architect, who is the main designer, and the person who is the responsible for fire protection design. So a fire protection design has to be signed by the same architect who is signing on the drawing and the person who is responsible for the fire protection design. So that's all about the fire protection plan. Now I'll talk something about the special requirement of different occupancies. This is the specific requirements of some buildings. So before giving the recommendation for any occupancy, we are taking the assumption that the building construction type is 1A and building surface finish to class 1. That is, all of any occupancy type and construction other than this type, then the design will be performance based. If there is any change of type 1A or class 1A, then design will be performance based. So with this assumption, there is some recommendations. For occupancy A1 and A2, that means for a single family dwelling or two family dwelling, for building having total floor area less than 500 meters square, fire detection and fixed fire assessment is not required. So this is a small type of building. You do not need detection or fixed firefighting. Building exceeding total floor area of 500 meters square shall have manual alarm system and portable extinguisher. So these are the, again I say, these are the minimum requirements. If you like to increase more than that, that is the owner's requirement. But as per code, this is the requirement. For occupancy A3, flat or apartment up to 33 meters, that means low-rise building, fixed firefighting arrangement shall not be required. Fixed firefighting shall not be required. No problem is required. No protection is required within the dwelling unit of high-rise flat and apartments. Manual alarm system and fixed fire system shall be provided in the landings of fire stair or in the lift lobby. as per the provision of this code. So you have to give hydrant system of for this type of system. For occupancy of 4 mass boarding houses up to 2-story height, fire detection, fire alarm, firefighting arrangement shall not be required. If it is building have 3-story এবং floor area less than 300 meter square shall not require fire detection and fire extinguishing arrangement. For floor area of 3-story building having more than 300 meter square per floor, remember per floor, and less than 33 meter height, that is it is low rise building, having central corridor with rooms on both sides, manual fire alarm system shall be provided along with the portable fire extinguisher. Instead of double loaded corridor, a single loaded corridor having 3 meter width shall not require any detection and fire arrangement system. So you may think, what is the double loaded or what is the single loaded? Actually, if have a common corridor, that is the two side is a building or working, two side is a residential area or boarding area, then it is called single loaded. If the corridor have both side has the rooms, then it is double loaded. If there is a 3 meter corridor, then there is nothing. That corridor can be used as a smoke-free area. That's why you do not need something. Instead of double loaded corridor, a single loaded corridor having 3 meter width shall not require any detection and free fire system, because the corridor itself gives you some safety because it is more than 3 meter width. Actually, if a distance 3 meter is always normally think to be a 1 hour fire rating. Normally, fire or smoke will not move more than 3 meter horizontally. That is the idea of this design. High-rise boarding house, mass and hotels manually operated electric fire alarm systems shall be operated along with the hydrant system. So always high-rise buildings need a hydrant system. Hotels, lodging house have different combinations, and there are different type of firefighting system. So you can see here the arrangement of this firefighting system depending on the height and the floor area. There are different combination of firefighting arrangement. So if I'm not reading all the points, so you can read from here, and I think you understand all these things very easily. So for educational low-rise building with open corridor, again, if his building is open corridor, which is very common to our Bangladesh, particularly outside the Dhaka. So the all education institute has a balcony, has a veranda, which is about 3 meter width. And fixed detection and fixed detection shall not be required. Where you have wide 3 meter wide veranda, you do not need some. High-rise building or building having central corridor with classroom on both sides, manually fire alarm hydrant system shall be required as per postal code. Single loaded open corridor having more than 3 meter or more shall have detection and manual system only. So you have to be careful about this corridor size and whether it is single loaded or double loaded. Where hydrants cannot be used to extinguish fire, in this case, area appropriate portable fire extinguisher applies shall be installed as per standard. Actually, for any education, there is some laboratories or other areas which is very sensitive area. In that area, you need some other than hydrant system. You need some portable extinguisher appliances and other things, particularly those special areas. This is some healthcare institutes. Here you need some portable fire extinguisher, fire detection and fire fixed fighting arrangements shall be required because it is very small size. But custodial C2, the similar thing is not required. For C3, C4, C5, manual operated electric fire alarm system shall be installed. Portable fire extinguisher application shall be installed. Healthcare facility, depending on type, there is a lot of variation. Manually operated electric fire alarm system or automatic fire system shall be installed in the duty room so that the duty personnel receives the fire warning well in advance. Portable fire extinguisher appliance shall be installed for low-rise healthcare facility building with more than 300 meter square floor area. Performance-based firefighting system shall be required. So you have needs performance design for healthcare. So you need some lot of detail for building like hospitals. For high-rise healthcare facility building, manually operated electric alarm system shall be provided along with the heightened system. For business class, actually for business class, there are a lot of arrangement, lot of designs, and corresponding to this lot of design, you need a lot of active fire protection. So there you have to. I am not going details of this. If you please read the left side type of buildings and the buildings areas and floors, and corresponding there are some suggestions for active fire protections. So if you use liquid or solvent other different types, then you have to give some different chemicals. So you have to think about the stress chemicals or other things present in the building, particularly electrical distribution panel or computer. So you have to think arrangement of this differently. For high-rise building, you have to be very careful about that. Manually operated electrical fire alarm system shall be provided along with the heightened system. For the industry, actually, industry has low hazard industry, moderate hazard industry G2. In spite of that, there is some criteria depending on the population. For G1, manually operated electric fire alarm system shall be installed with portable fire extinguisher or hydrant system when occupant loads are not more than 150. If it is more than 150, you have to give is performance based. Very straightforward. So you have to give a detail of this because its population is more than 150. For the moderate hazard industry, as of today is the garment industry. Among the moderate hazard industry, where large amount of occupants are densely populated in the building, the active fire protection shall be performance based. So actually, for this all these factories has very special arrangement, special design. So it has to be performance based. Fire safety requirement for such type of industry is elaborated as follows. It's a little bit elaborated. Where occupancy load is more than 150 per population area, per production area, you have to think about that word, per production area, shall have a minimum 3.9 meter square of area volume of per occupant. So there is a limitation of the air volume of that if the population is more than 150. Production, large production area, that there shall have direct exit from the ground floor. The exit door shall be used by only the occupant of the ground floor. So per production floor area must have direct access to the ground floor. Buildings less than 330 meter height, that is low-rise building, shall have an open stair and the interior stair. So you can remember what is open stair and on the interior stair. Open stair means a stair which have at least one side 50% open. That is open stair. One side 50% of that side wall is open. That is open stair. There is no chance for operation. If open is open stair and the interior stair shall be protected by fire-rated enclosure. So if it has an interior stair and then if that it has to be protected by a fire rated enclosure. So in that case, the stair must be fire rated enclosed. I think here first line is there is something wrong. Buildings less than 40 meter and shall have open stair, shall not have open stair, that the interior stair shall be protected, fire protected. If it is open stair, that is different. So if please sorry for that, there should be a not open stair, that will be interior stair. Occupant located above 30 meter or above all stairs shall have smoke-proof enclosure. So that is the thing. For high-rise building, all stair must be smoke-proof enclosure. Shall have smoke-proof enclosure. So there are some other things about the moderated industry. All windows, all openings, all exterior walls, possibly by occupant located above the 3 meter in height, shall be protected by grills. So all openings must be protected by grills so that they cannot jump. Actually, when there is a fire, people have a tendency to jump over. What happened in the last week in the Narayanganj? Some people jumped and died. So there should not be any open thing. All the raw materials, finished goods, and accessories shall be stored in control areas. The control area means a area which is 1 hour fire rated, at least 1 hour fire rated. So all raw material, finished goods, and accessories shall be stored in a control areas. Density of storage material per control area shall not be exceeded the standard value. Actually, there is lot of values which will ensure the standard one. So it is not can be said in a single line. So you have to see the standard values for storage. Cargo lift and passenger lift shall have a smoke-proof lift lobby. This is true if this cargo lift moves more than 2 stories. If it is more than 1 story, you do not need that one. It is not here, but you remember that if a cargo lift moves only 2 stories, it did not need a smoke-proof enclosure. If it moves beyond this 2 stories, it needs lift lobby. A smoke-proof lift lobby. Occupant load in a single effective undivided space shall not exceed 600. Occupant load in a single effective undivided space, or we can say occupant load in a compartmented area shall not exceed 600. Actually, if it is more than 600, you have to compartment that area. So you need some compartmentation of that area if it is more than 600. Areas and in process store shall have the hydrant system. So in any factory, there are 2 areas where we put some material to work in progress material. Other than a storage, there is a temporary storage. So the area and the process storage shall have hydrant system. In the utility occupancy areas, fire extinguishing system shall be installed as utilities. So it is already explained in my last lecture that what the utility should have. Up to 700 meter square single effective undivided space in a floor shall be installed with manual fire alarm system with portable fire extinguishing system or hydrant. So this is the maximum area that will be in a undivided space, and then undivided space must have individual alarm system and portable fire system. Above 700 meter square single effective area undivided space in a floor shall be fitted with manual fire alarm system and with hydrant system. So these are some criteria for the G2 system. Storage, it is different area. It totally depends on the type of storage. Manually operated electric fire alarm system shall be installed depending on the type of material to be stored. Performance by fire detection shall be maintained because the storage have different type of material, and you cannot ensure what is the type, what is the class of fire. So depending on the type of material, type of fire that can be happen, then we have to decide about the firefighting system that is to be performance based. And for moderate fire accident, that is must that all of it should be performance based because it is a risk area and it does not give any specific thing. Assembly have different combination, lot of combinations, so you have to read it. I'm not giving it just idea, just a very few idea, so you have to go in detail for this. Here is a very small some few points. You should not all abide by with this. You have particularly you have to read all this. Actually these are very few things. You should read all the things in detail. For a large assembly of 6 feet, all auditorium, corridor, greenhouse, green curtain area to assembly buildings shall be fitted with manual firefighting system, and the performing stage should preferably be converted with an automatic smart system. This is very special. That's why I'm saying that they, particularly in the performing stage, always that should be covered by an automatic fire smart system. This is very, and this is for fixed term system. Fixed seat. Actually, assembly have two types. One is fixed seat, another without fixed seat. So fixed seat is the big size, so we have to be careful about that. So I'm not repeating all other things. So please, sorry about that. The hazardous area, all hazardous occupancies shall be installed with automatic fire alarm and automatic fixed firefighting gases or foams or dry chemical system or compatible with the class of fire shall be installed. Because it's a hazardous, that is a totally isolated building that will be different from the other occupancies. That the hazardous depends on the type of material here is stored, so you have to design accordingly. Whatever type of chemical you use, whatever type of fire that can initiate, because depending on that type, there may be different type of fire, and you have to find that one. The garage are the same thing, so you have to fit with some fire rating area. It is a fire rating 1 hour fire rated, and again it depends on the size. If it is 7,500 square feet more than that, you have to compartmentalize. Here it is not written. You have to be careful about that. If size is more, then you have to be careful about the garage also. For occupancy utilities and miscellaneous, you have to go for an NFPA straightforward, because that will be a performance base and the type of building is different. Everything is different, so you have to go to the NFPA. Now I like to talk something about the Appendix B, fire protection consideration for venting and industry and storage. This appendix covers venting required for industry. Provisions applicable to factory and storage facility of large floor areas without dividing walls and enclosures. This is the special condition for this type of thing. So while considering this, we have two criteria. One is a fire or a smoke layer that does not enhance the burning. Remember that does not enhance the burning. That means the fire it generates, it produces something, smoke, which does not accelerate heating. It accelerates flaming. But there is some flame, there is some fire. The product of the fire enhances the flame again, so it accelerates. That is deflagration. So I will give you some idea about deflagration. Actually, there is another fire which we call detonation. That is exceeding the fire which is more than the sound velocity. What happened in Nimtoli and what happened in Chowk Bazar in Bangladesh? There is a chemical which is the fire speed was like the more than the sound velocity. That is the detonation that explodes. But in the fire in the Narangas is something like deflagration, and the fire in Nimtoli and then that is like detonation. But in our normal fire, that is the fire with the smoke. That is a fire like in a fat tower. This is the variation of this fire. The fire in Sparta is something in just fire and smoke, that is in fire in Banane, just for example. Fire in Naranganj, in some area, and some extent, particularly in the fifth floor or sixth floor, that is the deflagration. And in the Nimtali and in the Churihatta, and that is the detonation, and something little bit deflagration, and the end of the deflagration, but it is detonation. Actually, detonation and deflagration, there is a narrow band differences. The deflagration is the starting from the fire normal to the very high velocity. Something we are talking about the venting of fire and smoke that does not enhance burning rate. So this type of burning, you need to give some smoke-proof, smoke releasing vents. Venting requirement varies with the rate of combustion, composition of the combustion product, shape, size, packaging of the combustion material, as well as the size, height of the stock. So while designing the vent, you have to consider all these. Depending on the material, the deflagration not reach, but it is very close to the deflagration. So the rate of combustion may be such that there will be huge amount of smoke. So you have to design accordingly. Vent area required to achieve a mass flow rate through the vent that equals the mass rate of smoke production. So you have to make an estimate of that how much smoke can produce and what will be the size of your vent. Venting device shall operate automatically at the earliest sign of the fire, and if the temperature rise beyond 150, and then it will operate automatically. This automatic can be done by its design. It automatic can be done by automatic sensing or the other thing. Vent area should be size made the design of the performance of the NFPA 204 and maintained as per NFPA 204. So it will design according to 4 and maintain as per 4. Design of venting for sprinkler buildings shall be based on the performance analysis. While automatic experts are installed, the sprinkler shall operate before the vent system comes into operation. So if you're careful at that, the sprinkler shall operate before the vent system comes to operation. So you have to synchronize this in this way. In industrial building, exterior walls, windows shall not be accepted as satisfactory means of venting, but many may be reckoned as additional. That is an additional window door, that is additional, but you need vent. Window is not a vent, that is an addition. Releasing mechanism of vent closure shall be simple in operation and shall not be dependent on the electric power. Automatic operation shall be achieved by actuation of fusible links or other metal heat of smoke detectors by interlocking with the operation of the smoke system, or to open by counterweights utilizing the force of the gravity or spring. Vent shall be properly seated at the highest point of each area to be covered. Minimum vent open shall not be less than 1.25 meter in any direction. So that is the minimum size. Vent spacing shall be designed considering the fact that higher number of smaller vent is better than a smaller number of large vents. Now something about the deflagration venting. Deflagration is the subsonic propagation of the fire or smoke at a pressure about 0.5 bar. Deflagration vent design involves a lot of variables because there is a lot of variation of propagation. No venting recommendations are currently available for fast burning gases, such as hydrogen. Again, no venting recommendations are currently available for fast burning gases, such as hydrogen. So for hydrogen, there is actually this is very fast. This is actually not deflagration. This is something detonation. Fast burning gases. Be careful about the fast burning gas, as deflagration can readily be undergo transition to the detonation. That is the reason. So in that case, you should not design anything. Deflagration venting is provided for enclosure to minimize structural damage. Actually, detonation, when it is closed, it may explode at a certain stage because then deflagration transit to the detonation. That's why to minimize the explosion, so there will be some venting which will collapse first and it will release the pressure. The venting area shall be distributed as symmetrically and as eventually as possible. This is a part of the design distribution. The need for efflagration vents can be eliminated by the application of the explosion prevention technique described in NFPA 69. So you have to read for detailed design. As far as possible, hazard areas shall be segregated by means of firewalls and part walls to prevent spread of fire. Actually, for this type of fire, you expect deflagration, please segregate by means of firewalls and part walls or detach the building as far as possible. That is the main thing which should be done, should be done in Churihatta, in Nimthali. Those buildings should not be there. That should be there in other location. In Naranganj, this area where their fuel was there, that should be segregated by part wall or by totally detached area. That's all. Thank you everyone for listening me. Thank you everybody. Assalamu alaikum. Now question please. The second question is, what is the specific requirement for a standpipe and sprinkler system for G2 occupancy as per BNBC 2020? It was very much clear in the Accord Alliance guidelines. Why still it is not clear in BNBC? It was very much clear in Accord Alliance. I think it is not clear in Accord Alliance. Almost all area, they said it is sprinkler. Actually, BNBC do not, it says it is sprinkler. Accord Alliance, whatever they've done, you may know, in RSC now, they are changing almost everything. Out of 1600 garments factory under Accord, only 360 factory had got the permission. All other 1200, more than 1200 garments is lagging. They cannot satisfy Alliance Accord till now, after 7 years of Alliance Accord. So whatever you commented may not be true, because I am still working with RSC. I know the details. They are changing the things. So whatever they said at 2013, they changed in 2016, and now again they changed all the things. Most of the garment factory is suffering of these changing things. So that is not very standard by them. Actually, you need performance-based design for it, because every garment factory is a little bit different from each other. So another thing is, BNBC 2020 is not very specific to garment industry. Actually, for garment industry, you need some commentary. You need some special write of books detailed for detailed analysis. For G2 garments, again I say, 2020 is not saying now it is G2. They are saying it is G, because all garment factory are not same. It is different. Each and every garment factory is different. Their population different. Their materials different. Their arrangement different. So it has to be performance based. Another thing is, as per any Accord Alliance, they are saying up to 3-story building, the standpipe is required. But we say no. If the building is very high, is very wide, very population there, you need some standpipe and similar things. And as per sprinkler, BNBC do not say sprinkler is must. They always say is an optional, because sprinkler is a property protection system. We are talking about the life safety system. As per code, we always handle with the life safety system first. Property system is the owner's priority. He can save his own property as he wish, as he like. He can put his industry totally in air condition, as if he like to give comfort to his own worker. So this is not a mandatory thing. This is not the code compliance. This is the requirement of the person itself. Accord, whatever he doing this. It's a doing very good thing for the garment industry. But in many cases, in many more cases, they are doing, I think, much more, which is not must, which was not must. I don't know whether I can finish your answer. Is the requirement of 2 fire pump as a mandatory thing? Yes. Is a yes. Because otherwise there will be a standby. There should be a standby. It is mandatory. And how it is operated, that is, there is an option. As for NAPA, there is no option, but in BNBC there is an option. It can be diesel operated, it can be electric operated, if you have a second source. Yeah, dear sir, is there any alternative process to make it acceptable for the fire pump already installed in the negative section? Yes. Actually, RSC, there is some meeting in the RSC. I was one of the technical person with the Alliance Record, all person. We designed 2 things. One is by brake tank. If you have a brake tank connecting with your pump, then that will ensure initially, if there is a power force fluctuation, that will give you supply. In that case, you can handle the suction head. Another thing is, if you have negative suction up to a certain limit, depending on our capacity, pump NPSH, there is a pump capacity that we call it NPHH value. The suction it can develop. If it is much lower than that, if this negative suction is much lower than that, I am talking about the much, I am not quantifying this. If it is much lower than that, the pump must work. Only thing, as per NFPSA, there is some chance of reliability. But in any European standard, British standard, Indian standard, everybody accepts the suction head. In spite of that, for your information, all over the country, all over the world, all fire fighting vehicles, trucks, which using by firefighting people, fire service people in Bangladesh, they have hundreds of firefighting trucks. All are working with the centrifugal suction pipe system. They have suction. And in NFPA 1956, NFPA 1956, it allowed suction head. Only NFPA 20 modified this thing a few years back. Most probably they got some accident somewhere, they lost some reliability, so they emphasize to increase the reliability. But this is a very special for NFPA, not all other standard of the world. American, other than American, European, all Asian, they accept suction head, except NFPA. I think you understand. But this is a new requirement by Accord, which they introduced recently, not initially. Last one, the fire tank, water tank. If we select single tank for domestic use and fire use, so what is the rest of the question? For water tank, if we select single tank both domestic use and fire use, I think question is complete. Is not complete. Actually, yeah, yes, we can use single tank for both domestic and fire use, but you have to be careful about in any case, fire reserve cannot be used. So you have to put a valve or suction line for the domestic use at a height that always fire water use will be left there. But at the same time, you need some recirculation, otherwise the water quality will deteriorate because there will be some mossing. If the structure is a steel roof structure, as it required to fireproof all area, if Is it required to fireproof all area? You can see the table 331. You have the different rating of the structure. So you have to put the structure according to the requirement. You see this, my last lecture, I showed there are different class type 1, A, B, C, D, and the last one is unprotected. That is the steel structure. So you look how much height you need for the building. Corresponding, you had the different element, how much fire rating of the different element you need. Accordingly, you have to give fire protection. For more detail, if you have the chance of getting fire code for Vietnam, that have much more detail. If you can have your Vietnam fire code, it has everything detailed for steel structure. Unfortunately, or due to the different reason, BNBC don't have detail for steel structure. So for information, if you have like to have very detailed, you go for Vietnam building code. They have detail. You know that the roof part, actually the roof part has this conductivity with this some concrete. So it is a fire rating, but not total same, not same. So you have, is there any alternative? Yes, there is a lot of alternatives. There are a lot of alternatives. That I'm saying you can consult with the Vietnam code or you can consult with others. There are a lot of alternatives, but you need some form of fire rating of different elements, and that rating can be done by coating, by pasting cement, by pasting gypsum, by pasting all other materials. There are some lot of alternative materials. You can have a gypsum code that will give you some alternatives. If not carbon dioxide, what type of gaseous system of the fire extinguisher may be? There are a lot of halon groups. Halon groups. There are a lot of halon groups. So you can contact with the halon groups. There are a lot of gaseous halon types. Which type of stair? ALAR. I don't understand ALAR. Generally, for 7 or 8 story building, which type of stair system should be used? Actually, a stair system, I don't know that a stair system. Actually, depending on the position, interior or exterior, if it is interior, you have to make it fireproof. A stair, not a stair system, is a staircase, should be smoke proof. If it is internal, if it is external, there are a lot of design, different design. So in a single word, it's very difficult to say what type, which type. Actually, stair don't have city. Again, this type depends on the number of occupant you like to evacuate. So it is not that there's no direct answer of this. Again, what is the specific requirement for validation of alarm system for G2? Actually, G2 have, depending on the floor area, depending on the floor area, it varies. Depending on the fire protection other scenario, that is your class 1, type 1A, class 1, so it will vary. So is it manual or automatic? Detection system is always human. If there is a human surveillance is there, particularly in the floor area, at the working time, you do not need the detection automatic, but other than time, you need the automatic system. An alarm should be both manual and manual. A manual is much more reliable than the automatic one because there is a human being, but there is a less chance of false alarm. If manual, why? Because it is much more reliable, and actually there in G2 garment factory there are a lot of people is there. So actually there is every chance of false alarm, and most Bangladesh governments mostly suffering from false alarm. In generally, when you go to visit, maximum time you will find that they make it switched off because suffering from this false alarm. And actually, for to do anything automatic, you have to be very punctual about your maintenance, cleaning. If you do anything wrong, there is every chance of false alarm. It hampers a different way. As the garment factory, G2, not only, I'm not saying G2, it's garment factory, there is a huge number of people at the time of work. They can do it manually. If it is at night, we don't care, we think at the night, if there is no people is working there is no life safety issues. So the owner can think its own way, whether he like to, whatever he likes. So you have to think in that way. Actually, we are concerned about the life safety. It's the prime objective. Property safety, definitely we think, but it's secondary. As per code, we are serious about the life safety. What is the minimum height to be considered sprinkler system along with the hydro system? I don't understand the question. What is the minimum height to be considered? Height of what? Height of the building? I'm not sure. Actually, for sprinkler, as per code, sprinkler is not compulsory to do anything. And depending on the height and the area, it had some suggestion specific requirement for the hydrant. Only very few area in BNBC there is sprinkler. Like just for assembly theater area, stage area, they suggest sprinkler. And few other area, very few area, normally BNBC do not suggest sprinkler, irrespective of the height. As we have previously considered 20-meter height to consider sprinkler system. I don't know what do you mean by we. Actually, this height is not true. In BNBC 2006, nowhere it is sprinkler is mandatory. In no case it was mandatory. Only accord make it mandatory. I make mandatory, and I have different opinion. The sprinkler, is different to say how much it is needed. Because sprinkler is not, again I'm saying, is not a life safety system. It is a property protection system. It is a property, as per NFPA definition. There is an NFPA definition. Whatever is the life safety system, what is property protection system? As per NFPA definition, this is not a life safety system. It is a property protection system. What is the base position to measure height of the building if there are underground floors? The definition is the entrance. It is not a ground floor. Is the entrance of the building is said to be is the zero position of the building. Underground is not used to measure the height of the building. This is the custom. This is how it is defined. It is very difficult to avoid the false alarm. There are dual systems. You can make a combination of systems. If a number 3 or 4 altogether come to a conclusion, then you can combine the systems for the false alarm. You hear a signal from all these 3 or 4, then it will take the signal from all these three, then you can detect, or you can reduce your sensitivity. Is there any latest smoke detection type which is good for garment industry? It is every day something is coming from the new. Actually, every day there are a lot of research. Neither ensure the false alarm, but you can reduce by adding much more constraints, by coupling more than 2 detector or 3 detector. So whatever you do, if you reduce the sensitivity, you reduce chance of getting alarm from the detector. So you have to compromise, you have to add. Just for your idea, is an American data, is NFPA research, only 40% of the detector give proper signal in America out of 100 fire. I repeat, out of 100 fire in America, only 40% detector detect properly. This is USA system. This research is done by NFPA. So remember that one. This is a statistical data of NFPA published by NFPA for America. 30% they don't have detector. 30% they give wrong detection, no detection. Only 40% give proper detection. This is American system. So how you get proper detection in Bangladesh? I don't understand. And more data about the UK, almost similar, with 10% variation only. They have same thing. It is for UK, this is for USA. And all result is done by NFPA research. The next question, as you have said to use single type of detector, what should we consider to use multi-detector? What should we consider? You should consider the detection efficiency. You should consider the false alarm. You should consider the air flowing tendency of our nature, because our nature, we always keep open our windows. This is our nature. We will put our exhaust system open. This is our nature. In Europe, in America, they don't keep it open. In Europe, you never find any fan, any ceiling fan. Their room is closed. That is air conditioned. They control heat and cold temperature. But our nature, our habit is totally different. In the night, we open our windows. Nothing, never it is found in America or Europe. In Europe, it is never you find that. In some area of America, you can find that, because America has different weather condition. So you have to think in that way also. You can think another way also. The death of fire incident in Russia is the highest of the world. 30, 70 times than more our data. It is 17 times more than our country of Bangladesh. Though somebody says Bangladesh don't have proper data. Yes, if we have 100% error, 200% error, what will happen? Then Russia had, if had 200% error, Russia have 35 times more death per incident in Russia than Bangladesh. So you can imagine what is the real scenario. So you should understand something, statistics of the world. The next question is, can we keep hydrant system without fire pump connection, but to use for CMS connection, which can be used by fire brigade? Yes, if you have very high water supply, like in what do I say, Fakirapur, there is a very high water tank. So if you have that on that way, or if I wish in future we have hydrant with high pressure line, then we can use without pump up to a certain height. I don't know why we can't hit that one. Yeah. But I wish I should have a hydrant system in our country in Dhaka, if God gives us the chance. Because fire brigade has their own pump, they can handle the pressure if we don't have pump.
Professor Halali, This will be our last question now. There's too many questions. So
Yeah.
so we need to stop after this last one.
Okay, thank you.
Thank you, Professor. No.
There are a lot of questions. What can I do? I think I didn't finish half of them. So I choose just one. How
That's
should
fine.
we consider coverage area of the detector? How should we consider coverage area of the detector that is given by the manufacturer? All detector have its own manufacturer coverage area. So take that area as a coverage and have some other parameters of building size, building locations, room size, beam locations. There are a lot of other factors. But first thing is what is said by the detector manufacturer. Second thing is your building arrangement, your room size, your beam areas, beam depths, a lot of things. So in single sentence, it is very difficult to say. So sometimes I have to say, sorry, and I like to keep my email open to all of you. If you have a question, please ring me. You give me mail. I shall try my best to give your answer. My email is Hilali 1956. I repeat, Hilali HELALI at the rate, sorry, 1956. Hilali 1956 at gmail.com. So I have to say goodbye to everybody.